Good afternoon. In this session, I would like to talk about the communication architecture for achieving data separation between the systems in Mercoin. I am Kohei Noda, FinTech Architect. First, short self-introduction. My name is Kohei Noda. After joining Mixi in 2014, I worked as a plant engineer and backend engineer and an engineering manager in various positions in gaming development. Then last April, I joined Mercoin as an architect. This January, the architects of the Mercoin formed FinTech Architect team, so I'm now working in that team. Now, what I'm going to talk about today is here. First, what is the data separation between the system it means in Mercoin? And second is how we can achieve this without compromising the developer's experience. And finally, I would like to summarize. And first, let me explain the data separation of the Mercoin system is. That means that the customer data held by Mercoin and Mercari and Merpay systems cannot be easily linked to each other. We call this data separation, and for example, Mercoin handles crypto asset. So the Mercoin system stores the crypto asset information of the customer, while the Mercari and Merpay system store the customer's address, name, and other personal information. If someone has access to this information at the same time, he or she will be able to obtain information about who owns how much cryptographic asset and where. This information is valuable, and it can be sold to someone or directly used for some other purpose. So, in order to provide the Mercoin service, it was necessary to ensure that this data could not be linked between and the system and Mercari Merpay system, even it was an internal employee. That was the requirement, and that is called data separation. And the basic mechanism for achieving this is the separation of the systems. In the first place, as shown in here, the system of Mercoin, Mercari, and Merpay, and that are separated from each other, and the classification of the systems means that the Mercoin employees cannot only access Mercoin customer data, while Mercari, Merpay employees can only access the Mercari, Merpay customer data. This chart shows that Mercari, Merpay employees can access to Mercoin's customer data. The reverse is also true. Mercoin employees cannot access to Mercari Merpay customer data. However, with this system separation alone, if the incident happens on Mercoin and the customer data were to leak out, even if the employee only had privilege to access to Mercari Merpay, with the Mercoin Merpay system and could access to the customer data of the system and the Mercoin customer data at the same time, it would be possible to link them. And in the worst case, if not only Mercoin but also the customer data of the Mercari Merpay were leaked at the same time, those who have access to the data of the both parties would be able to exploit. In order to solve this, Mercoin has decided to implement the separation of the user IDs. This means that different IDs are assigned to the same customer in Mercoin, Mercari, and Merpay system, and the data is stored and handled in the system. And this makes it impossible to link data, even if data from both parties is linked, since the different IDs are assigned to the same customer. This figure is the one that I have mentioned a little while ago. Even if there is a customer data from it's been leaked in Mercari Merpay, would not be able to immediately link it to the customer data. However, by separating the user IDs in this way, it is impossible to link them in case of the data leakage. But on the other hand, the Mercoin system depends on the Mercari Merpay system. In fact, the Mercoin service allows users to buy and sell Bitcoin with the Mercari application. So it is necessary to link with the Mercari Merpay system. Then, if the Mercoin system and Mercari Merpay system use different IDs, the two systems will not be able to know which user ID is used by which customer. So even if they communicate each other, they will not be able to actually work together, or cannot be integrated. And therefore, when communicating, it is necessary to convert the IDs into IDs that can identify the customers that can be recognized by each systems before communication. For this reason, in the linkage between the Mercoin and Mercari Merpay system, we have prepared internal ID as well as external ID shown in here. Simply put, there's a customer's user ID for each Mercoin and Mercari Merpay, and it should be possible to convert them into each other's user ID. However, if we do this, it would be difficult to convert Mercoin to Merpay ID. If you do that, for example, when you think that sending communications from Mercoin to Mercari Merpay, when you're trying to send the communications within Mercoin, and it will be converted to the Mercoin Merpay ID before it is sent. If it is done within the Mercoin service, then it would be no different from the situation where the Mercoin side actually knows the IDs of the Mercari Merpay users. In this case, the employees who have access the authority of to convert the IDs will be able to link the Mercoin customer data with the Mercoin and Mercari and Merpay data. And therefore, we have introduced an external ID for communication, and we use two types of different IDs for the conversion. In the following explanations, I will refer to this as an internal ID, and which is used in Mercoin, and this is going to be called Mercoin user ID. And for communication, I will say a Mercoin PPID. And vice versa, the internal ID, and I will say the Merpay user ID. And for the communication, Mercari Merpay PPID. And PPID, and which is the external ID, and this is a new word, and this is based on the public specifications and OpenID Connect related, and therefore to refer to the details, and there is an engineering log which was created by the member of the IDP team of Mercari. So if you want to learn more, and please refer to that. I explained there four types of the ID: internal ID, external ID, Mercoin ID, and Mercoin Merpay ID. And 4 IDs exist. And the case of the communication from Mercoin to Mercari, the following steps are required. This is a conversion step. The first step is a service at the Mercoin side, and which converts the Mercoin user ID to the Mercoin PPID and send the request. And the next is a Mercari and Merpay service, and the request is received, and a PPID of Mercoin contained in the received request is converted to the Mercari user ID. When the response is generated and the Mercoin user ID contained in the response must be converted to Mercoin PPID in order to return the response to Mercoin. And finally, that Mercoin converted the Mercoin PPID to Mercoin's internal user ID and processed the received response. And it's quite complicated steps. And I believe that you probably have understood, but in terms of the with the user ID data separation, the usage of the data in malicious manner and case can be reduced. And however, there are 4 types of the IDs in the first place, and the ID system and ID conversion is complicated with many steps of the communication and the conversion as well. In this case, where system integrations are required and a number of communications are performed. The cost of implementing this ID conversion in each microservice will be very high. So, to summarize it, we wanted to protect user data by using different user ID between systems, and we do not want to deteriorate developers' experience and enable rapid development. Where we wanted to create an architecture that would satisfy these requirements simultaneously. And from here, I would like to talk about the how we develop that architecture that would satisfy these requirements. To give you an idea of the kind of developer experience we were aiming for, we are adapting a microservice across the Mercari group. So communication amount among the system will be a microservice, through the microservice. If the communication between these microservice is internal to Mercoin, and only the user ID that if you focus on that in the development, in the case, automatically it can be converted into the external or the ID. And or if you were called, if you're at the calling side of the API, in the case, before you get it is delivered and it is converted as a user ID, and that's what we wanted to achieve. Now, how we have realized this is that in Mercari group, and there's some exception, but microservice communication is defined with the protocol buffers, IDL, basically. So, request and the response will be defined accordingly as a protobuf messages. Therefore, by using this message definition, the user ID included in the message is automatically converted to an appropriate ID on the communication route without the developer being aware of it, and therefore it is possible to create a situation in which the developer does not need to be aware of that ID conversion.
This is the conversion of the IDs contained in the protobuf message. As an example of Go implementation, the image is to call the ID conversion according to the message in the protobuf and the direction of the ID conversion, for example, whether it is from sector ID to PPID or user ID or PPID to user ID. So converting all the IDs contained in the message and replacing the value is performed by this method. So as you can see here, and we need to know which fields contain the values for the ID conversion. So for this information, annotations are performed in a protofile definition using a protocol buffer mechanism called custom options. This is an example of annotating protofile. For example, if there is a request to retrieve the user information called getUserRequest, and there is a user ID, this field is annotated to enable ID conversion. In the same way, the response is annotated with user ID. Here is a custom option definition for that purpose. The ID conversion contained in the protobuf message described so far was performed at the 2 points on the communication path. One is the gRPC client interceptor in the caller side, and the other is the gateway widely used in Mercari in Kohei, where the ID conversion is performed. The overall communication path looks like this. The caller and Kohei here, and ID conversion on the caller side is performed by the gRPC interceptor included in a microservice. The interceptor converts the ID and sends the request to the other microservice via gateway. The ID conversion is performed again at the gateway and reaches the Kohei microservice. I've written 2 examples of Mercari and Mercoin systems. Also, that reverse is the exactly same as I have already explained. Before explaining the 2 ID conversion on the communication path, let me briefly explain the ID provider in the figure. This is the service that has a mapping between user ID and PPID. This service is managed by the IDP team within Mercari and provides an API to convert between user ID and PPID. As for caller side ID conversions and also gRPC interceptor handles within the microservice. So gRPC and client interceptor can perform the various operations when calling the API from a gRPC client. So here, again, the number of various operations are possible for a gRPC client interceptor, and one of those options is the ability to modify the request response. So in this gRPC client interceptor, the ID is contained in the message are retrieved and converted, returned back, and then sent to the gateway. It is not necessary to do this setting every time you make an API call. If you set up the gRPC client to intercept once, and it will be called automatically thereafter. The interceptor converts the caller user ID into caller PPID when the request is sent, and when the response is back, caller PPID is converted to caller user ID. For Kohei conversion is done at the gateway, which is already used a lot within Mercari. So gateway handles the traffic from outside, from the internet or the customer of the app. So the requests come from a customer's apps, so that this gateway handles such a traffic. So it's similar to what we call API gateway. so which is the entry point for routing to microservice. So in this gateway, we perform an ID conversion on the gRPC call messages that comes from the caller when the request is received. PPID is converted to a user ID that the call leads side ID, and the message is actually routed to the microservice behind the scene. When the response comes back from the microservice, the callee ID included, and that is converted back to caller's PPID. You may wonder why we are doing this. So at gRPC, server interceptor exists, with just like a client interceptor. Callee microservice request response modification is possible. So why not caller MS but gateway for ID conversion? Well, from the caller's PPID to the call lead's user ID should be done in a limited number of components. Well, call leads receive a number of different calls with PPID. So this time, the Mercoin and Mercari system, but possibly other solutions. And recipient microservices received an arbitrary ID and has issued performed ID conversion, and which required high privileges because data at both sides can be associated. So such kind of the data association is possible given the high privileges. So therefore, we refrain from giving that high privilege to each microservice. Instead, gave that privilege to only gateway. This also eliminates the need to install the server interceptors in the microservices on the callee side. This is the ID conversion and communication flow. First, a message is sent from caller's microservice to a gRPC interceptor. ID conversion is performed, and message is sent to the callee's gateway, and callee's microservice processes the message using only the internal user ID, generates a response, and returns it to the gateway. And these gateways and the gRPC client interceptor conversion performed. So these gateway and gRPC client interceptor realize such a developer experience. So specifically, the only things the development needs to do is to install the gRPC client interceptor at the caller side. This is a one-time step. It also annotates the user ID, and it's filled in a protobuf message used for communication. So by simply doing these two things, the developer can now handle only the user ID and make API calls between systems, just like an internal communication, without having to be aware of ID conversion. We so far covered the case of normal synchronous communication and API calls, but in reality, there are asynchronous communication between systems. Asynchronous communication uses the message queues. In addition, most of the services in the Mercari group uses Google Cloud Pub Sub. We needed to free developers from ID conversion steps in such an environment. Here is a diagram of the communication that made it happen. In addition to the Cloud Pub Sub topic, and we see a service called the Pub Sub Pusher, which is not only for ID conversion, but also for the ability to receive a pull subscription from a Cloud Pub Sub topic and convert it to a gRPC request and send the gRPC request to the subscribers. Well, due to implementing pull subscription for asynchronous communication, same request again noted for Cloud Pub subscribe topic and the destination to send the gRPC request described as a manifest, so it becomes a custom resource implemented behind the scenes. And we have extended this function. So the pub sub pusher has now ID conversion. Within pub sub pusher, user ID is converted to subscriber PP ID. So this is different from a synchronous call because here it is converted to subscriber's PP ID. So that reason is complex. So again, if you're interested, please read our IDP tech blog. The pub sub pusher usually handles internal communication, so it sends a request to the gateway. Then the gateway is converted to this gRPC, just like as a synchronous API. So when the request is received and sent, the same identity conversion is performed. Now we provide the same developer experience for asynchronous communications. So all the developers have to do is to write the pub sub pusher configuration file to enable ID translation and gateway pushers. I'd like to conclude with a summary. Mercoin was able to achieve high level of data privacy protection by separating the user IDs between systems, making it impossible to tie data together. On the other hand, the complex task of ID conversion, which is necessary, has been efficiently developed by introducing the architecture that transparently performs ID conversion on the communication path. In addition, microservice developers do not need to be aware of ID conversion when implementing microservices. As an added bonus, I think this transparent ID conversion was possible because most microservices were implemented in Go, and everyone is using the gRPC and the protobufs. Finally, here are remaining issues. I mentioned earlier that most of the environment use Go, but there are still PHP and some non-Go implementation remains in Mercari. When this environment calls current setting of the gRPC interceptor, it's not possible to handle. So if we try to solve this problem in the future, instead of intercepting and putting into a microservice, we could, for example, go through some kind of proxy on the communication path where the caller could also be converted. Well, traceability when investigating a defect is a problem because it is not possible to link Mercari user data with the actual Mercoin customer data in the event of a customer problem, making it difficult to investigate. We have yet prepared a good mechanism for this. The last one is the linking of the data other than user ID. For example, if you have a history of product purchase on the Mercari and share it with Mercoin, so the same data can be stored in the respective DB, so they can be linked without user ID. So this is a quite important issue, and we don't have a good solution yet, but we are considering how to prevent these IDs from being linked. So that's all for the presentation. Thank you very much.